All right, I think it's time for us to begin. It's 1:30. Hello, everyone. Welcome to the solar system session. My name is Mario Juric. I'm the science unit, solar system science unit lead I'm at the University of Washington. I'm also the DM liaison to the Solar System Science Collaboration, Ruben. And you've heard from me earlier this morning reciting ChatGPT generated poetry. So that was me this morning. This is, those of you who know me know that this is not my usual state. This is me in my usual state. So this will be me today. Since we originally, I was going to do this talk, the talk that I gave earlier this morning here, but like 2 weeks ago, we got upgraded to business. So I also asked ChatGPT to create this photo, but then I asked it, hey, can you make these two people look like me and Melissa? And then here's the stuff on nightmares. That's what we're going to look like at the end of this project. So this time for this session, what I'm going to try to do is I'm going to try to keep it shorter. We have a set of excellent talks. You've heard a lot of what I wanted to say earlier this morning. I'm just going to run through some of the things that I haven't mentioned, and then I'll spend most of the time at the last 2 or 3 slides giving you a sense of what's coming over the next couple of months. And then we can have more time for discussion, and given this is not a huge group here, we can take it where you want to go. So I'm going to talk about 3 things. One is data preview 1. What is in it. 2 is Ruben first look. The Ruben first look part is going to look very similar to what you've seen this morning, so I'm going to go quickly through it. And then 3, we're going to go through the to-do list for the solar system team. Data preview 1, we announced some 3 weeks ago. A lot of hard work to get this first data release out, even though it's only CompCam data. This is the first time we're exercising all the processes and so on, but I'm happy to say that it worked. The paper describing what has been done and how is at rtn-095.lsst.io. It's called the Verisi Rubin Observatory Data Preview 1. I love descriptive names. And in these slides, I'm going to use figures from this paper, but also from a slightly older report called Interim Report on CompCam on the Sky campaign, which has a little bit more information actually than we ended up putting into the DP1 paper as well. Key things about DP1, it has 7 pointings in effect. Here are the 6. This is from the paper. 47 tuck, very dense field. If you care about knowing about the pipeline performance in dense field, this is the field to look at. 4 next dwarf. EC, oh, this is really out of focus. I think this is Euclid, Chandra Deep Field South, Euclid Deep Field South, Ruben SV, and Seagull. All these fields have been looked at many, many times over. The depth is quite significant. So these are the bands, and this is the number of observations per band. You're going to see very large numbers here. When co-added, this is what they roughly look like. If you look at the color bars, those signify the magnitudes. So the numbers are about 26.5 up to almost 27 in some of them. So this is roughly the depth of Ruben first look. If you wonder what you're going to find here, except that here you really have coads, you really have PSFs or FITS files to work with. So you can do science on these. Image quality is worse than what we'll have for Ruben, for LSST. You'll notice that the peaks are around 1.1 or so in almost all the bands. We were working hard to push that further down. But again, this is not terrible. This is something that a lot of science can be done with, as we've seen earlier this morning. The photometric repeatability, though, is excellent. So photometry has been really good. Overall, these are the plots from the DMTN that even I can't read. I apologize on behalf of the projector. The top is defocused. And this is one of the things that enabled some of the papers that we're going to see, that we're going to hear about later today, because we see the similar behavior on LSST cam as well. This was the 7 field that I left off of that first image with that had only 6 out of 7 fields, because this one is near and dear to our hearts. It's the field that's on the ecliptic. It's the ecliptic latitude field, Rubin SV 38.7, which was imaged with roughly wide, fast, deep cadence during, roughly wide, fast, deep separation in days, but highly oversampled within each day during early commissioning, and that enabled us to find asteroids. So now we come to asteroids. These are the first 2 that we were allowed to show a couple of weeks ago, just GIFs. These are known asteroids, the first publicly released images of known asteroids detected by Rubin. But this is the interesting result from DP1. So we've detected 93 new objects, or we were able to link 93 new objects. The way to think about this is primarily a test of the linking algorithms, and we're happy to say that they worked. We've also reported all of these to the Minor Planet Center, 2,229 observations. We're also super happy to say that once we send this in, I think we got confirmations within 5 to 10 minutes. Everything just worked smoothly. And then the last thing I'm going to show about DP1 is the astrometry. So astrometry has been serving us well on DP1. Here's an example of the astrometric residuals for sources that relative to the for known sources relative to the closest match, no matter how far that match is. So you're going to see that some of them are really far out. These are objects that have been incorrectly linked or incorrectly matched. But the vast majority is here in the center. It's so close that you can't actually tell what it is. But quantitatively, the bias that we see in astrometry is no larger than roughly 30 milliarc seconds in the center. I should have said bias, not RMS. So this is great, and this is something that we're going to continue to monitor as we get into LSST CAM era, and to make sure that it continues being excellent. All right, how to access all these data? Go to data.lsst.cloud, log into the science platform, and they're all there in the tables. I'm not going to go more in depth here than that. The session that was here on Monday, the DP1 session that Melissa put together and that Sarah Greenstreet gave a talk in, are most relevant for this. So please just go review that session if you have any questions about how to access this, how to log in, what are the tables that are relevant for solar system, etc. The other thing you can do is just simply get these data from the Minor Planet Center. There's not that much of it, or from Solar System Science Collaboration Channel, and I think somebody already uploaded it there just as an ADES file. But I would really love if you would try out at least the science platform, even though it's a small set of data, because the more and more data we get, the more you will start relying on this research. So it's better to try it out now and give us some feedback about how things are working for solar system science. All right, Rubin First Look Asteroid Dataset. I've talked about this, so let me just kind of quickly skip this, because I'm assuming you've all been here for the plenary. Many reported discoveries, many reported observations. This is the overview from Sarah's paper. We decided also to use that paper as a vehicle to create a reference really for First Look, because it wasn't originally meant to be a science themed release, but then it turned out to be when we published Asteroids. So go read Sarah's paper once it's published on the details of what was submitted to the MPC. Here's the orbital distribution I showed earlier this morning. Oh, this is a slide that I didn't show earlier this morning. There's an excellent orbit viewer built by our EPO team. It's on a domain called orbitviewer.app. It's easy to remember. If you want to get a sense for 3D where these objects are in the solar system, this is fantastic. Just it works very well, very nicely on your phone. Just go there, use it, try it out. It's great. I love it. I've shown this morning, so let me skip through most of these slides. And let me go through the looking ahead part. So before I go through this, like if you've ever listened to investor calls with stock analysts and so on, then they start with something like this. So I'm going to start with explaining this is a forward-looking, these are all forward-looking statements, and I'm going to stand behind any of them. If they turn out not to be true, you have no grounds on which to sue me. That said, here's what's on our to-do list for the next couple of months. When I say our, I mean the Solar System Science unit and the part of the data management team that's working on making all the solar system pipelines work. So one of the critical things that we want to finish is the 3i analysis of the comet. And because we found an interesting effect there that the astrometry of the comet that we're measuring seems to be biased on order of 100 milliards seconds or so relative to what everybody else is reporting. And we're taking that seriously because when we send those 400,000 observations to the MPC, or 400,000 daily, we'll soon overwhelm the MPC database with our observations. If we have an unidentified bias in there, that will not be a good day or month or year for the entire community. So this is the top priority list for us for now. Just make sure there's something didn't degrade in the astrometry relative to what we saw in DP1. We think we can sort this out in the next week or two. These fields are very different relative to what we usually have. They're crowded. We had to use all kinds of tricks to measure this extended object, but still, better safe than sorry. After this is done, we'll start submitting known asteroids from DP1 to the Minor Planet Center. That's going to be a couple of thousand measurements as well. The next interesting submission is going to be the known asteroids from Rubin First Look data that were submitted to the Minor Planet Center. So these are asteroids that are already known, but now just measured in Rubin First Look. When you see Sarah's talk and what she was able to do with new discoveries from First Look, that's the kind of thing you're going to be able to do with these known asteroids as well. And there's about 440,000 observations of these. And then we want to develop a more robust operational pixel pipeline knowledge, which in normal human speak means we who usually work on astrometry, on text files, if you will, numbers, need to learn how to run the pipelines all the way from the pixels to the final product, so we can make the analysis and QAing faster. This is an internal thing with us in the project, how we structured it. I think we just have to do it. This we're projecting should all happen in August or so. Then we're going to prepare for the alert stream, complete importing healing cell algorithms into the task framework, and then work around some prompt products database delays. I am almost done. This is where I said that I'm going to be short. I've shown you this image of the SV survey. That's the second part of the to-do list. So we're working on doing the bulk analysis of the SV survey. We've got about 5 weeks worth of data, but we don't have templates yet. So we're trying to work around that with building source-based catalogs, then run linking at scale, and then be ready for early bulk submissions. And we're aiming to do that in September, probably when the telescope shuts down. And once the public alerts arrive, that's going to be showtime. We're going to have to run linking on a daily basis together with QA and make daily submissions to the Minor Planet Center. So to make a fairly long story short, over the next month or two, you should start seeing more and more submissions from Rubin to the MPC. And through that avenue, more and more data released. This is all pending getting the proper approvals and so on, but I'm pretty optimistic that they will arrive. And that means science. That means that things really are starting. So I'll stop here, hand it over to Meg.
We've got time for very quick questions.
And ask, yeah, take a question.
So we already have one on Zoom. So Wes Fraser wanted to ask, for linking, can the astrometric residual outliers just be auto-rejected?
Yes, but it's not an outlier at that level. We're talking about outliers at 20, 30, 50, occasionally 100 milliards second levels. Sorry, it's not an outlier, it's systematic. That's the issue.
All right. Matt, if you want to come up to get ready.
Right.
If there's any other quick question in the audience while we're changing the laptop presentation, we can take that. Perfect. And on to the next talk.
Thank you, Meg. And let me introduce Matt Payne from the Minor Planet Center.
Russell. Okay. Thanks very much for having me. Okay. Minor Planet Center is supposed to act as the single point of receipt and redistribution for astrometric data of all of the solar system stuff. NEOs, asteroids, comets, satellites, other things that you like in the solar system. And we do that for a couple of thousand different observatories around the world. And we do data validation, orbit fitting, etc. And then we redistribute the data free to whoever wants to use it for education, science, whatever purpose they want. A lot of stuff gets used for planetary defense kind of stuff. And the Planetary Defense Coordination Office is who funds us. And so I'm now super proud that Ruben has joined the group of observatories that submit data to us. But as you can guess, Ruben is not going to be one of the typical observatories that submit to us. So at the moment, over the past few years, the Minor Planet Center sort of averages around about 50 million observations from a range of different surveys. The numbers are dominated by planetary defense funded surveys like Atlas, Catalina, Pan-STARRS. But we forecast that Ruben is going to be sending to us somewhere in the region of 250 million a year. So factor of 5 increase. A couple of years after from now, the NEO Surveyor mission is probably going to send somewhere in the region of 250 million a year as well. So I'm looking at an order of magnitude increase to my data flow over the course of a couple of year timescale. And so that has driven all of my sleepless nights and development. I will just give you some flavors of the sort of things that we've been sort of working on, changing, developing, improving in order to try and cope with all of this anticipated increase. So one of them is our data ingest, how we get the data into our system, how we receive it, validate it, stick it into the database, all of this kind of stuff has been done on sort of privately owned in-house servers, and we've shifted all of that code onto AWS, tested it at length over the past couple of years, both internally and with the Ruben Solar System team. So that is now sort of battle tested and sort of ready to go. And we want to switch over that ingest route in a couple of weeks' time at around a time of full moon. Apparently I don't have permission to play something or other. So that should get done in a couple of weeks' time. That should be completely transparent to the end user community. Everything will stay the same. You just put stuff into the same endpoint. Nothing will change as far as you're concerned, except that things will happen a lot quicker. And it will enable sort of future improved reporting of various like different features of things. So just all good things, but nothing you have to worry about. Then on the back end, our sort of processing pipelines do a whole range of different sort of things. There's a whole intricate web of stuff that happens behind the scenes to validate data, do orbit fitting, link together, track alerts, keep stuff stored in the database, distribute it out to people, etc. And so we've been basically moving all of that off bare metal servers, putting it onto virtualized clusters of like virtual machines, running various different Docker containers, compartmentalized services, everything kind of like made more modern and more bulletproof and a lot easier to deploy. And so the reason that we've been sort of going through all of this, other than having an exciting software development challenge, is because it makes a lot of our infrastructure kind of a lot more robust, a lot more easily reproducible and easily deployable. So for instance, all of that AWS infrastructure I talked about for ingesting things, I can sort of clone all of that with a push of a button, make a separate version if I want for testing and development. And similar for the internal components for the database, I can sort of make a copy of those. I can make a copy of the processing pipeline, and I can redeploy all of these in a sort of copy type system. So which we have done, referred to as a sandbox system. You can use it for isolated testing. So we've been doing that with the Ruben Solar System team over the past sort of year or so, taking those various different sort of commissioning data sets that Mario just mentioned, and behind the scenes in this isolated private environment, repeatedly putting in the observations, the submissions again and again and again and again, testing that everything's all right on the submission side and everything's all right on the processing side, getting all of the sort of kinks ironed out in the system, allowing us to sort of do it in a sort of safe and private environment. That's also available to any other sort of teams, such as the NEO Surveyor mission, and anyone else that wants to sort of view this, we're happy to spin these kind of things up. So all of that testing went towards June 23rd, when instead of the data going into the sandbox system, it went into our public system for the first time. And so, as Mario sort of described, and there's about 2,100 unique objects in there covering NEOs, main belt objects, some TNOs, some Trojans, etc., and over 340,000 observations in there. So that observation sort of cadence isn't what we're going to be seeing typically going forward for LSST discoveries in sort of main survey mode, when we just expect somewhere in a region of half a dozen to a dozen observations at the point of discovery. These ones have over 100 observations at the point of discovery. So it's really easy to do orbit fitting for these, and it's awesome to do light curve analysis on these kind of things. The astrometric residuals, sort of internal, the relative astrometric residuals there look exquisite out to 24th magnitude. The absolute sort of precision, as Mario said, is like still being analyzed and refined, but all of this looks great at the moment. And then a couple of days after June 23rd, on June 27th, there was the ComCam data that came in to us, and that is now also sort of available as these sort of 90 or so new objects. I'll mention that all of this testing should theoretically have made the submission of all of this live data easy peasy and totally smooth sailing. It wasn't quite as stress-free as I would have liked. As Mario mentioned this morning, several hours of he and Joachim banging their heads against kind of getting the damn data submitted on the day. And on our side, behind the scenes, there was various hours of banging my head against why the f doesn't this work? We tested this for fucking months. And it basically is driven by sort of slight differences between sort of the production and the sandbox systems, like slight things that need manually deploying versus everything sort of being exactly self-similar. So lesson learned is to stop having that. So over the past few weeks, we've migrated all of the AWS components that we use onto Terraform so that they are literally identical when we redeploy them. And we've also done a significant amount of work, but we're still in the process of doing the same for all of our internal components as well, using Ansible, which allows you to basically redeploy everything, sort of infrastructure as code, sort of at the sort of push of a button, so that we can have less stress in my life. That's all what it is. It's all about being selfish. I don't have permission to play that file. That's awesome. I already did request that access, but fuck it. It's a lovely picture that is available on archive, and it's a lovely animation of a survey taking place, the Science Validation Survey, covering the ecliptic, about a third of the ecliptic, plus or minus 10 degrees. And you can imagine in your minds this filling in dynamically in a pictorial manner. And then I would say, isn't it good? Yeah, it's great. And what would be the point of that? Well, as Mario said, it's covering basically about a third of the ecliptic, it's covering about a third of the main belt. So it's going to observe around about 500,000 known objects. So you're going to get loads of observations that are already in the bag, and a few more that are coming up over the next month, plus a similar number of new objects. There's hundreds of thousands of new objects have effectively already been imaged and are just waiting to be analyzed and submitted to me. So that's what I'm looking forward to. So over the next few weeks, I'm looking forward to this additional commissioning data that Mario was talking about of known objects, both from the sort of ComCam and LSSTCam, so that we can do some benchmarking of the absolute astrometric accuracy for those, get all of that data public, then get all of these hundreds of thousands of new things that are in the Science Validation Survey. And in preparation for that, I shall continue doing some various pieces of infrastructure, sort of refinement and rollout. And one of the big things that I'm sort of want after this development is done is to revitalize our public-facing data services. And so one of the things I'm looking for is suggestions from people in the community for awesome things they would like me to do. The end.
All right, I think we have time for one quick question, if there are any. I'll take, I guess, co-chair's prerogative. How do we give you feedback? Can I just throw it in the Slack channel? Would you like us to email it to you? What's the best way?
If you can come talk to me, stick it in the Slack channel, I'll see that. And also we have our sort of like a help desk contact thing that's available from our website. Stick stuff in there as well.
You can say the help desk ticket has been quite useful. Yes, Mario, while the Colin gets up.
While Colin sets up, no, sorry, Sarah, is it? Who's next? I think it's Sarah. While Sarah sets up, so I just want to read an email I sent to Matt on June 23rd. I said, hi everyone, from our end, this looked great. Everything seemed to run smoothly after the initial hiccups. And then Matt's reply was, "Erg, URGH, it's been a long day." But we got 300,000 observations through in a day for a system that's never seen the MPC before. So I count that as a success.
I can hold one. You can use this. These are live. All right. Hi, everybody. You have probably seen these results a couple times now. I shared this in the RFL DP1 show and tell session yesterday, and Mario talked about it this morning as well. But I'm back for the solar system session as well. So talking about this on behalf of myself, but also all of my collaborators who are listed up here. They've been working pretty tirelessly over the last couple of weeks to get all of these results out. Also, as we've heard many times, there were these 2,000 solar system objects that were discovered and released as part of the Rubin First Look event that took place on June 23rd, so just over a month ago. As you can see in this version of the First Look image on the right here, you can see some of the positions of where these solar system objects are. They almost kind of look like trails here, but these are actually the individual positions of the asteroids within each of the images that were used to make this co-added stack. And because they almost look like lines, you can tell how densely sampled these observations are for these 2,000 solar system objects, which makes this data set really great for being able to plot light curves like the beautiful example on the left here of one of these asteroids, so that then we can try to get rotation periods for them. This has also been said multiple times, but I'm going to say it again anyway. These 340,000 detections of these 2,103 unique solar system objects have been released. They were submitted to the Minor Planet Center immediately following the First Look event. So they've been public for just over a month. They're queryable from the MPC. This morning, Mario provided a link to the observation file that was provided by the B612 Asteroid Institute. We also put together a community science team tutorial notebook that walks you through how to retrieve these observations or orbits from the Minor Planet Center for all of these objects, which are available on the tutorial notebook GitHub page, as well as on the Rubin Science platform. So all of this work that I'm going to talk about uses this public data set. Since most of these are new discoveries, when we're doing our rotation period determination, there aren't known periods for us to be able to compare our results to. So in order to assess the robustness of our results, we use two different methods for being able to model these light curves and determine rotation periods for these objects. One of those is a multi-band Lumsgargle method, and the other is a high-order Fourier analysis. We also manually analyzed light curves for all 2,000 objects in order to be able to better determine our reliability thresholds and calculated colors for all the objects. So jumping right to the results, since I don't have very long, we found rotation periods for 75 objects. These are the ones that have reliable rotation periods that we're happy to share. These are all 4 main belt asteroids that have diameters ranging from 150 meters to 1.5 kilometers. So kind of on the small end, as well as semi-major axes that span the full width of the semi-major axis as well of the main asteroid belt. Among these 75 objects are 16 fast rotators that have rotation periods ranging from about 13 minutes to right at about the 2.2 hour spin barrier limit for these asteroids. Again, these are all main belt asteroids. They also span the similar diameter and semi-major axes range as the larger 75 object sample. When we put these fast rotators on the canonical rotation period versus size for these objects, here on the left, I'm showing the gray points are all of the numbered objects in the JPL Horizons catalog that have known rotation periods. The blue dots are the fast rotators with known rotation periods and reliable rotation periods, so less than 30% uncertainties. And then the red X's are all of the Rubin fast rotators that we find in this first look data set. And you can see that we're starting to fill in this sub-kilometer fast rotation period area. On the right for comparison is figure 1 from Hu et al. 2021 with the light curve database data here. And very nicely, they split this up between the main belt asteroids and the near Earth asteroids. So you can see pretty much all of these small fast rotators that are known are NEAs. But as a reminder, all of these Rubin fast rotators are main belt asteroids. So we're sampling a part of the solar system population that we haven't really been able to sample before, and also kind of pushing the size limit for these fast rotators even farther. There's 2 more objects to add to this, which Mario showed this morning as well, and I mentioned yesterday, that are these super fast rotators that are also kind of in this large category that are spinning really quickly. To look at them a little closer, the one on the right has a diameter of about 0.5 kilometer and a rotation period of 3.87 minutes. The one on the left is about 400 meters across with a period of 1.88 minutes, making this Rubin discovery the fastest spinning known asteroid with a diameter of larger than about 400 meters or so, which is pretty exciting. It's also a pretty exceptional claim. So we've been doing a lot of extra validation testing and stuff to make sure that we're really confident in this, and we're about 90% sure that this is actually a real rotation period. So I see May getting ready to stand up, so I'll just go to my take-home message here. You've heard it said many times that this really is a fantastic data set. It's also a public data set. We want to make sure that people know about it. If you haven't played around with it yet, I encourage you to do so. I've had a lot of fun getting to play with this data set. And this is just one example of the exciting things that I know are in that data set and what Rubin can do, but also all of this data that's coming, all of the associated objects are going to be released very soon. So this is all just the beginning. And I'm really excited to see all of the solar system science that we as a community can do with all this data. Thanks.
Questions in the room?
Really cool stuff, Sarah. Do you ever see any eclipsing binary asteroids in the light curves?
Yeah, we haven't looked for any binaries, and let's see, this way. So we've kind of looked a little bit at the shape of these light curves. We haven't had much of a chance because we've only had a couple weeks to be playing with this to try to see if there might be any eclipsing binaries. Some of these even look like they might be contact binaries with like the really deep V shape in their light curve. So that's something we definitely like to take a look at, but we haven't been able to do so far.
And that ties into Wes Fraser's comment that says the same thing. It looked like Mario showed a contact like light curve. So asking something similar, how many asteroids in the Rubin samples show that kind of light curve shape?
Yeah, so this is just the 75 objects that had reliable rotation periods. We did plot light curves for all of the 2000 objects. We didn't actually look at count up what fraction of these might have that very sharp peak that could be contact binaries, but it looks just from eyeballing this, there's quite a few in here.
All right, thank you. Thank you, Sarah.
Thank you.
Colin Chandler is going to tell us more about 3i. We keep teasing it, but now you're going to get a little bit more info about it.
Great, thank you. Awesome, great. Well, hello, everybody. I'm Colin Ryan Chandler. I'm a product scientist for Link Frameworks at the University of Washington Dirac Institute. I'll talk to you today about this interstellar object you keep hearing about. I went with the ChatGPT generated title of first interstellar object observed by Rubin Observatory, which had not dawned on me until it told me that, which kind of was a bit shocking. Anyway, here we go. So I think we all know what interstellar objects are at this point, but just in case, these are objects that are not actually bound to our sun's gravity per se. People do like to remind me that it could have been ejected eons ago and come back, but I think let's just call them objects from other star systems for simplicity. So this is the third one discovered. The first one was found in 2017, which was Oumuamua, and there was another discovered in 2019, which was Borisov. We all know of Oumuamua. This is the artist concept of the spaceship, and it's pretty great. So I just decided to leave it as is. It's not a real observation. It says so illustration right there. And this third one is the focus of our talk today. And I just wanted to say this is for the image stacking nerds in the audience. This is a minimum stack, which is absolutely obscene because I could take the minimum value of a huge number of pixels because we have that much flux coming from Rubin. And it's just a very pretty picture. So the discovery and the campaign that we did. So the object itself was discovered on July 1st, the know-it-all. There's a couple of additional review papers to talk more about the circumstances. Within 8 hours, we started investigating it actively inside the team. We found 10 serendipitous observations of it, and there's some caveats, like those are indeed donuts there, but we still found it. It's that little magenta circle, and I'm quite proud of this. And some people are horrified that I'm showing it, but I do like to show it because there is good stuff even in some of the not perfectly tuned. It's also the figure that's supposed to remind me to say that Rubin is still in commissioning and things are still being tuned up, and that so all of what we're doing is part of commissioning here, and so that's been pretty effective. And the object is at the center in these panels of the precovery observations that we had. The middle one and the one to the left of it, it is in front of a very bright star. It is slightly disentangleable, but not worth it, in my opinion. I did use the same pipeline as for Rubin Comet Catcher, so shameless plug for my citizen science project, which is live now at cometcatchers.net. And this was all done on the Rubin Science platform. We keep hearing about it. Highly recommend you check that out. So these are like the earliest large aperture observations of this object. There's really only so much I can say in a 5-minute talk, except that you can see besides the image that it looks like it has a coma, you could do some quantitative analysis to say that there is photometric excess. So the left one is a radio profile showing a star in orange versus the object's profile in blue. And since there's this nice big gap there, you can assume that that's coming from something else, that photometric excess. The 2D version is at the right, where you see stars in the quad panel on the right, which are nice concentric rings. And then at the left, you can see there's some extendedness to that source there. So all of this to say that Rubin is pretty ideally suited for this. And I just, not to be like bragging or anything, but it blows my mind that we have, like, for 1 pixel for some of these other survey telescopes, we have 25 to 85 pixels in Rubin pixels, which is just killer. So we did get additional observations. We did just maybe nudge the telescope over a little bit. Thank you, certain people who did that, and we really appreciate it. And so we got a bunch of observations. Again, commissioning, so there are additional challenges that we kindly were imparted to us by the commissioning team. But it's nevertheless, here's some great observations of the object. We did also get to participate in TO testing. And so this is another area where we've helped to contribute because we just heard about this gravity wave, for example, that was observed. We got to break a bunch of things ahead of time with this object as part of that process. There's a lot of lessons learned. I don't know if people care about these lessons, but I think it's something important for me to just say. And that is that a lot of this was done on the Rubin Science platform. Yeah, I know we really chased hard the guider chips. And so they probably aren't going to like me for saying this, but there is data on the guider chips and you could get really lucky and like win a lottery. So just know that there are now some mechanisms in place and ability, some knowledge to actually retrieve stuff out of those. That's where 3i was compared to the guider chip. So we didn't win that lottery, but it's pretty cool. We're working on improvements in crowded fields. It's in a crowded field the whole time. And so that's presented all kinds of interesting challenges. Yeah, the deblending system also, it's nice to see that it works really well. There's this figure down there that shows it working mostly very well. Actually, this projector makes it look like it's working perfectly. So let's just go with that. That's great. Yeah, I mentioned some of these other things already. The astrometric performance is something that we're chasing. And I just keep stepping back and like, wow, we are arguing over like 20 milliarcseconds. So it's a really nice luxury problem. It's not really a luxury problem, but I consider it to be just amazing that we're in that point. And then collaboration is really great too. So I cannot emphasize that enough. And so people keep asking me about it. So I want to talk specifically about that and just how that played out here, because this is like the common hallway question. So initially we heard about it, like I said, and within a few hours we're chasing it. This is in the commissioning team, and then we rope in all of these poor people at Rubin because, you know, like, how do we do this thing? And then we got approvals from I don't know who, but that's great. So they eventually said that we were allowed to do things with these pixels in ways that I don't understand. And then we were able to open it up to the Solar System Science Collaboration and to the Rubin community and builders at large as well. And so this ended up being sort of a really large collaboration, and certainly some people helped to do a lot of wrangling, which we'll come back to. We did crest this morning 300 authors, by the way. Not past the deadline, don't panic, just people we hadn't added yet. So I was amazed 300 people were in there. And including 80 people who actively added text and did work on the actual work and the manuscript and did other things too. 2 minutes, wow, I'm so ahead of time. So I just want to have a special thanks to Pedro, who hopefully is online, and my undergrad student, Devanshi Singh, who managed all the author lists, wrote the introduction, did all the citations, and a million other things. And she's just amazing. And Mario and Meg are here because there are way too many people involved, and I really appreciate that management. Henry Shea for putting up with all my nonsense, who is in here, and thank you, you know what you did. Jelko and Bob for getting agency approval or whatever it was. And then the agencies, who I don't even know who they are, thank you for letting us do this, that's great. And to every one of the 300 authors, because you're an author on the paper because you did something that made this possible, and I am very thankful for that. So as a recap, we recovered 10 observations. We took a bunch more. There's more coming. We're not done with this paper. And you can see the paper as it is now on arXiv. There's a link. It is viewable there. Yeah, and so again, collaboration with the Solar System Science Collaboration and Rubin. I hope this is not going to become a one-off thing. I think it worked really well, and I'm super excited about that part of it. And let's get more science, because this thing is really awesome. So I think that's it. Oh yeah. The AO is really working, that's what you see. There.
In one of your collages of pictures, you had in the lower right-hand corner a guider one, and it looks like the stars are trailed. Were you doing non-sidereal tracking at the rate of 3i?
No. So if we
Yeah,
had
that one.
won the lottery, and I really would have bought lottery tickets for everybody, this is a 400 by 400 pixel readout on the guider chip, and they do a readout in a different way. It's a little bit more like you could think. I think of it like the JWST way of doing recurrent reads over and over, and so those are actually like buildups of pixels of readouts that are happening. So yeah, the short answer is no. It's not quite like that.
It's a 4K by 4K chip, but only the region of interest is read out. And it just so happened that the region of interest was not where the comet was. And the reason why we went hard after this one, Colin did, was this is June 2nd. So if we got this one, we would have had an observation a month before discovery. But we weren't that lucky.
But we tried really hard.
Any other questions?
Hi, Siegfried Eckel, UC. I just want to say like a very big thank you to Colin and Mario and everybody who was like working really hard on this, because if you weren't part of the story, there was so much manual labor going into this, because now you think everything is automated and everything works so well, but it's still commissioning, right? So all this data like it had to be basically hand plucked and hand curated, and so it was a huge amount of effort. So thank you again for this.
Let's thank Colin again. Okay. Next,
I stayed on time.
Next we have Meg Schwam, the chair of the Solar System, co-chair of the Solar System Science Collaboration. And there we go.
All right, let's see if I can keep to time. But I thought I would sort of talk about where the hell are we going as a collaboration. So just to remind people in the room who might not be as familiar, this is our sort of leadership within the collaboration. So we are divided by working groups based on population as well as software and infrastructure building. So again, all of these people are the ones that, although you often hear me and Colin, it is all of these people that are helping to sort of steer the ship. So again, just again, highlight the fact that these are the people that are helping really steer the leadership, but also there's lots of ways you can get involved as our working groups will be ramping up. And our Techno Signatures think tank. So really just to highlight that although you may be thinking that the working groups have been pretty quiet because we've been waiting for data, we're going to see things ramp up, particularly over the next few months with more telecons and things like that. And then along the way, over the past few years, the working groups have been punctuating their activity to help with specific things that have come up, like in-kind contributions or the TOs. So I just want to reiterate, I think, where the solar system science collaboration's role has been and where I think we're going. So we've been advocating for Rubin solar system science and LSST science. I don't think that's going to change. I think it's important because we can give that perspective of the community. We want Rubin to do the best, but we also want to encourage that we can do the best science with certain tweaks, which we've encouraged in Cadence. We've been organizing preparatory work. And I think we're facilitating conversations. The data will be in the MPC. There'll be a lot of value of the things that are within the RSP and the proprietary data products. And so I think our job is facilitating in the collaboration leadership conversations, right, and connecting different members before the data flows and as it is. Just to highlight building that is that we're trying to get people to talk more. So if you want and to give a lightning talk on August 3rd, whether or not, or rather 13th, whether you're available or not, you can record it and we'll play it. So you go to the QR code, you have emails from me that say this, you give a 1 minute, 2 minute talk of what you're up to. Also, we have seminars, thanks to Carrie and Maria, our early career reps. They have been leading the charge on this. So we're trying to have now every other month or twice a semester, such an online seminar. So we've had ones by Jeja Covelars, we've had one by Mario, and more to come. So that form will is a suggestion form. So if you would like someone to talk on something, or you have something you want to give an hour-long talk to the collaboration, use that QR code. Okay, so part of getting people together, I want to highlight, we've had our last solar system readiness sprint. That is no more. So Oxford was the last readiness sprint because we're exiting that phase. So we did that in September. We got people together, which was really great. But just to highlight, we're now entering that new phase. So while we've been doing that, along the way, we've been giving feedback on cadence. So lots of ways we've been interacting with the Survey Cadence Optimization Committee, pushing on incremental templates, looking about the Northern Ecliptic Spur. Some of this I talked about yesterday, but just to highlight that, we've been thinking and continually talking about things that are important to us, including TOs. So for small potential impactors where we need to get orbits, and astrometry, where Rubin with its big field of view and photometric precision and astrometric precision are needed. So continuing to advocate where people have come to us with things that could be done in commissioning. So just to highlight that's been going on. I also want to say, looking forward in the future, we want to make sure people who've got predictions that we can compare to get them out and publicize. So I'm really excited that we have that plus our software being advertised as well. And so the first software papers in our focus issue at AAS Journals and hosted at JJ, but you can put it anywhere in the AAS Journals ecosystem. They've been published. So this is, again, an avenue really encouraged because it's one-stop shop. If you're looking for community software, you can go here and it'll be open till at least December 2028. Same thing for predictions. We now have this hosted by PSJ. Again, you can submit to any journal within AAS Journals ecosystem and it will go in this focus issue and the first set of predictions. This focus issue we expect to close in December 2027 because hopefully by then we'll have new predictions based on LSST data. But the idea is to advertise your predictions of what the yields should be for different populations or different things within the LSST solar system data that then once we get data and people are analyzing it, you can go and compare to. So again, closes in December 2027. So plenty of time to get your papers in. Want to talk about just that also the next generation of the leadership will be coming into play. So we will be having a co-chair, working group lead, application coordinator, think tank lead, elections, new call for early representatives. So We have the list of the people that are stepping down, the people that are staying. Colin's running for re-election, so that's going to be coming out. Nominations will be due later in August, voting closer to the end of the year. You have an email about voting about code of conduct updates. I want to highlight really where we're going, and that this was the animation that Matt Payne couldn't show, that I can. I didn't do this on purpose, but here it is. So this is the SV survey, and you can actually see 3i moving through and out the field, so there will be more observations of it. But look at how much data on the ecliptic we are going to get from the data preview 2 when it is out. And so this data set, doesn't matter if it's not perfect, we know it's to make the telescope work. It's still going to find lots of amazing things in it. And I think that's something to be really excited about, and something that we as a community are going to be diving into and producing really great results for. Okay, so the other thing that I'm just wanting to, I'm a pessimist and I'm putting like happy things on slides, that there's so much science we can do with prompt products in the first 2 years, and beyond, but just to highlight Jake Kurlander's results that show that for asteroids, TNOs, NEOs, we get 70% of those discoveries in the first 2 years, which means we're going to have orbits, we're going to have detections and lots of different things of just 2 years of prompt products. So again, like so much science we can do, put us in coach, we're ready to go, get those prompt products flowing. And so I think it's more like that that's going to start happening very soon in this survey. Just take that soccer ball, football, and change it into a solar system object of your choice. I think that is what's going to happen when you log on to the RSP, right, in a couple months. Again, you've heard all about this, but I want to give you it in the different perspective, which is I feel like the solar system collaboration came in and we helped some of the lead Avengers, right? I'm like coming in, they're very beleaguered and tired. And we're like, here's some interpretation. Here's things that you weren't thinking of. And so again, just to highlight that fact of like, it was like, look to your left, right? And then people coming in. So just highlighting, I think, that really important part of that synergy, and that people were ready to go. They understood Rubin, how it works, right? What it's going to do. And so really seeing that we were organized enough to jump in with such little notice, right? We're ready to go. So this is my interpretation of what happened. But just to really highlight that point. Insert your favorite Avenger, whoever it is, as you. So really just to highlight that point. And really just to say, to end really before Mario kicks me off stage very soon, that thing about the status of where we are, I looked at our software roadmap, which was written as the like, oh my God, we don't know, like what have we not built that we need? And shockingly, as I looked at this, I was like, oh yeah, so we have Circa and there's KB mod and layups being developed and the dev pool contributions doing this. And my point is not to go through all of it. These are the high priority stuff we wanted before year one. And there's like mostly in everything, there's a name of somebody building a community tool. And I think that's really exciting that that is happening. And even both things that were like, we would be really nice to have and important after year one, there's lots of different things, including it was built at the Link Frameworks hackathon over the weekend, right, are being sort of ticked off the list. So I'm really optimistic that we are ready to go. Now there's lots more we can do. And so the point is, come to Belfast if you can in February. Mid-February, we're going to hack on the data that we have from prompt products that'll be available. And we're going to get cool, interesting science out of it. And if you can't make it to that, or you can come back around because we want to do this again in the summer, but in Seattle, we're the home of prompt products, the home of solar system processing for Rubin, right? And so again, I think I'm really excited for what we're going to get just from what I'm seeing from this meeting in 3i. So you've seen this before. And again, am I on time? Yes. All I really want to say is, right, everything changes in the next few months. There's so much more we could do to prepare, but we're ready. This has been the moment I was afraid of, is that we as a community wouldn't be ready. And I think everyone who jumped in for 3i, ready to go. The fact that we have all these software that has been built, people thinking about this and the other presentations, we're ready, put us in, coach, take us off the bench. And that I think is the super exciting thing. And I'm so excited to see what we do as a community and want to hear what else you want us as a collaboration to be doing to help facilitate that. So that's my optimistic pitch. And I'm the pessimist.
All right, questions for Meg?
or the Kermit wave, or the Joko wave, if you're, if you're that excited. There we go, I've got one. So.
Sure. Since I said thank you to the other guys, thanks, Meg, for being, a fearless leader and plowing the solar system science collaboration along. Like, you've been really instrumental to this success, and Colin too, of course. So thank you very much for your service.
Thanks, and I didn't plant that. But again, I guess it's really thank you to everybody, because it's been such a team effort as well. So it's been awesome to have everyone in the leadership.
As Meg likes to be called, she is the Iron Lady of our collaboration. That's an internal joke for the SSSC and everyone in the UK. Any other questions? Maybe I have a quick one. What's your thinking about DP2 data releases? And I know there's been a lot of discussion about whether to add more observations or not. What's the collaboration's view on this?
I think the collaboration's view is put us in, we want data as soon as possible. And I think really it's about getting data to everybody. And I think prompt products are not designed to be perfect. They're designed to be coming out daily, and there's so much science we can do from that. There's also a lot of amazing science we need with a calibrated data set. And that's what, data releases and previews are. So I think it's really important to get that as soon as possible out, because we can do lots of science, and that also gives us a better picture of what's going on for data releases. So prompt processing helps with a lot of that, but it's both of those. And so I argue we are in the boat, put this out as early as possible and get it out to as many people, and figure out where people need different things that would need to be augmented, figure out other ways out of the box to help them.
Excellent. Thank you. We've heard the message. Thanks again, Meg. And next on the schedule is Carrie Hall.
Great. Perfect. Awesome. Thank you. Hi, my name is Carrie Holt. I'm an LSSTA Catalyst postdoc fellow working with Tim Lister at Las Cumbres Observatory. And today I'm going to talk to you about the follow-up coordination website for solar system objects that we've been working on. And it is called FOMO, which stands for Follow-up Observations of Moving Objects. Not that I need to tell the people in this room, but I'm going to tell you anyway, that we're coming up on a new era. LSST is going to discover so many more solar system objects than ever before, and also a lot of faint objects, which means that large telescope time is going to be coveted and limited for follow-up, which means coordination is going to be critical to maximizing the science return of these discoveries. There's going to be many moving pieces, observers, telescopes, data streams, and being able to centralize this as much as possible will be really helpful. Since we have a very recent example, I thought I would talk a little bit about it, about how we coordinate now, besides just like emails between people for coordinating some other observations. For these large scale things, like for past interstellar objects, including 3I, these coordination efforts have generally involved like a fillable spreadsheet. So this is an example of one put together by Daryl Seligman and co, and it's a pretty beautiful spreadsheet, I must say. And I think this is just really awesome because it shows a desire to coordinate, which is great. And this sort of strategy is good for now, but it's not going to be sustainable in the future, because this sort of method requires someone to take initiative. Who that someone is or how that works, what if two people take initiative at the same time, can get pretty complicated. Also, as much as you want to widespread this information, a lot of times it still ends up with people in the know if somebody's not on a mailing list, if somebody doesn't know somebody. Also, if now they're going to get more and more objects, if you have more objects you're coordinating on, it's different locations for the different objects, it can get complicated. And finally, I'll just say these sort of spreadsheets require manual updates. So somebody says they're observing and then you don't know, did it happen? Was it weathered out? What are the results? Do we have to try again? Because people are excited about their data. They don't want to have to go back and manually enter it. So some of the goals for our system for FOMO is to really create a centralized system to coordinate follow-up observations between community members. So part of this is going to be a single place for an overview of proposals and facilities for TOO observations for exceptional objects. Also going to include tools to plan and optimize observations across facilities. We also want to increase automation to handle the increased target load efficiently and have a sort of single reference point for follow-up status and observation history. And this is going to allow us to have better tracking from alert to observation to data and publication. So just to give you kind of update of where we're at with it now. So we're using Tom Toolkit as our base. And if you want to view more about Tom Toolkit and all the amazing features in it, you can read the link. But we're also working on additional features to build on top of that. So for ingestion, we can ingest from Minor Planet Center and JPL. We are working on integrating community broker filters and eventually RAFTS, which we'll hear about later. Hope we'll be able to integrate with that. Still working on design details. For planning, our FEMIS generation is nearing completion, which is pretty much the basis that we need for all planning tools. And facility status work is being worked on partially by Heroic, which is a SIMA-led project that gives the status of different facilities as far as is the dome open, what instruments on it, the weather. So we'll be able to implement that in as well. For robotic observations, we have LCO, Gemini, and SOAR already for scheduling. ESO is coming soon, and we also would like to, we're also trying to better support manual facilities. And if people have thoughts on that, I would really love to talk to you on about what the best way to interact with that. And then for user proposal management, we have implemented a simplified user sign up. Right now, the default is open view only. You can see all the ingested objects. You can see where the upcoming planned observations. But then the enhanced proposal management aspect is underway. So I thought I would take this time to give a little bit of a walkthrough, an overview of how we envision the system playing out as an example to give you the idea. As an example for some of my favorite objects, measure comets. So let's say that Ruben has just discovered a comet outburst. FOMO is made aware of the outburst via brokers, maybe our new community filter on Antares, which just got announced as one of the ones chosen. FOMO ingests it into the database along with the latest orbital elements. On the FOMO webpage, I can view all of the ingested objects and I can filter sort so that I can find recently added outbursting comets because that's what I want to know about. I click on this new outbursting comet and I'm taken to an object page where I can see all the related information in one place, including the orbital elements, physical parameters, links to other related pages. And then I can also see all of the pending and completed observations from other users. So I'm thinking about what I might want to do with my observing. So I'm checking FOMO to see if Gemini South is open, what instrument is on it. I'm also looking at the calendar and I see Tim has an observing night on SOAR, but it's not until next week. So I'm thinking of maybe triggering my Gemini TOO, and I'm able to plan everything I need and see when the comet is up using FOMO. So I decided to trigger my TOO and I am able to continually check the status of that observation. And then when it is observed, I can click a link taking me directly to the data products. So that's hopefully gives you just a general overview of what we envision this kind of working like. So maybe when 4i is discovered, the community will know exactly where to look to coordinate this follow-up in the future. So I just want to end with saying that we are still taking feedback on a lot of these components. So if there's anything you think we might have missed, if there's any functionalities we haven't considered, we'd love to hear from you. Ultimately, we want you all to use this. So we would like to hear your needs. So stay tuned and we'll try to keep you updated. I'll take some questions now, but you can also email me or Tim in the Slack, come talk to me. All avenues open. Thanks.
Questions for Carrie? Henry.
Hi, Carrie. Nice work. So I noticed at the beginning, you mentioned the status of completed observations as a desired feature, but you didn't mention it in that workflow that you just showed.
Yeah.
Is that something that's easy to implement in the facilities that you're working with now, or is that tricky or whatever?
No, yeah, that's already a part of the TOM toolkit for the, these robotic facilities of it's pending, it's happening, it's completed automatically in there. Yeah.
Great. And can you get like weather conditions on that night and stuff like that? Is that?
That's something that we're working on, like with the heroic
Okay.
that I talked about. That's the sort of thing that they're going to be able to, that they're working on, that we will be able to include. It's going to be implemented in TOM toolkit and therefore easily implementable for us.
Awesome.
Any other questions?
Gary, could you go back to the slide you had on the workflow?
On this one?
That's
or-
one, that's perfect, yeah.
Okay.
I can't help but notice there's an awful lot of work being done by Carrie and Tim in that scenario.
Yes.
I wondered if you consider, or if whether it's possible to automate any of that.
From the, yes, I'd like to just take a look at things, but in theory, especially with the, yes, I don't know what aspect that you're asking for as far as going straight from alert to me knowing I want to automatically do that. That's a lot of, that gives me some anxiety because I do want to look at it, but in theory, you can have a pretty seamless automatic pipeline from ingestion to observation. And also too, I did mention, but even having a little bit more, you can create some of these templates for your observations ahead of time. So it can be even faster, even if you do want to look at it.
Thank you.
So there's a question on Slack. Wes Frazier was asking, is there a table view of what observations have already occurred?
Yeah, yes.
All right, let's thank Carrie again. Right, next is David Trilling, who's going to talk about SNAPS, the Solar System Notification Alert Processing System.
Thank you. I'm David Trilling. I'm going to talk about SNAPS, the Solar System Notification Alert Processing System. This is our team at NAU, Northern Arizona University, from both computer science and astronomy. And we have a lot of students here, undergrads and grad students. I'll point out Aaron Clark, who's sitting right there, and I'll come back to Aaron in just a moment. So just let me tell you briefly about SNAPS. SNAPS is a downstream LSST broker that is dedicated to solar system science. Our goals are the following. Number one, ingest alert data from moving objects at ZTF and LSST. Number two, derive various properties, colors and light curves and so on. Number three, identify individual and population outliers. Number four, serve this data to the community through a web page, an outgoing alert stream, and an API. And number five, do science related to small bodies. So here's some updates since you last heard from me. We hired a software engineer. This is 8 exclamation points right there. This has been a total game changer for us. We created a logo, so now we're big time because we have a logo. And this actually was designed, you can see it in the corner, except it's covered up by that Zoom thing. Designed by undergraduate students from NAU's Visual Design Lab. That was really fun to work with them. And we have stickers. They're sitting in a box right there, so come get stickers at the end. We have lots of new students, lots of technical improvements, and lots of new science. I have only 7 minutes. I'm just going to kind of zoom through a couple of those things. This is my one page on science. There's lots more to talk about, but just as a review, we have this architecture paper and snapshot 1, which is our first data release. We've worked on aliasing and period solutions, population outliers, combining ZTF and test data. And then we have a number of forthcoming papers, including Maria Chernyavskaya's forthcoming paper on super fast rotating asteroids. Sarah, where'd Sarah go? You'll be interested in that one. There you are. Aaron Clark's forthcoming paper. Aaron is sitting right there about active asteroids. Did you go see Aaron's poster? If not, why not? It's hanging up over there. And I've got a paper coming here, which will be snapshot 2, so our second data release. And importantly, it will also have our webpage and our API. And the target is to have this on archive by October 1st. It's not going to be, published or in press or anything by then, but at least to get it out, and I'll come back to October 1st in just a moment, get it out so that people can start to understand how to access our tools. There are many other papers coming related to both astronomy and computer science. Okay, I want to spend just a little time here. This is our current view of our feature table and our timeline. So on the left here, I've got these features. This says already operating. This says by October 1st, 2025, and this is mid-2026, which is some indeterminate middle distance date. Why October 1st? Well, we had this expectation a while ago that that would more or less be the beginning of science operations. And so, okay, let's just pick that date. Whether it actually is exactly that date or not, it doesn't really matter. That's going to be our target for some of these products. So on the left here, let's go through these one by one. Feature ingesting incoming alerts. It's complicated. We were doing that. We're on pause right now for a technical reason. But anyway, no problem to get back to that. And that'll be a green box by October 1st. Derived properties, that's also complicated because if we're not ingesting, then we're not deriving properties. But that infrastructure does exist. And so that's why that's green. And that will be green on October 1st as well. Ancillary data, this is actually pretty good. This is catalogs that are mostly static catalogs. So an ingest from TESS, Atlas, MPC, which is not exactly static, but is not as dynamic as the alert stream, NeoEyes, and so on. That's pretty good, and that will continue to be very solid October 1st. Serve via web page. So we have for many years had an internal web page that is very useful for our group, but is really completely gnarly and unusable by any other human. And so we've built from scratch version 2.0. Our testing is underway. I'll show you that in just a moment. We'll have basic functionality by October 1st, and we'll have full functionality in the middle distance. Our API also exists. We're doing internal testing. Again, basic functionality October 1st and full functionality in mid-2026. And our outgoing Kafka alert stream will have, again, basic functionality October 1st, and will be full on in the middle distance. Let's see. Did that work? Okay, so this is a very hard to read screenshot of our web page as it currently stands. There is also a light mode, so you don't have to kill your eyes to look at this one. But anyway, just to give you an idea of what kind of things you'll see, you could enter an object ID here, your favorite asteroid, 1, 2, 3, 4, 5. You can choose which databases you want to include. That says alert stream, I think is what that says. Yes, and so when there are outgoing alerts, they'll be listed here in order of most recent at the top. You can store your recent queries. You could store your favorites here. There's a bunch of other tools. There's a lot of help, documentation, and so on. So that's the basic functionality that will be available to the community October 1st. There's other stuff that sits on our internal site that will port over through next year. Okay, so let me end with a couple questions for you. How do I get information about an individual object? Well, if you wanted that, you would query our webpage. And you might even set a favorite, which is very fun, and then your asteroid's always there whenever you come back. How do I get information about a set of objects? You could use the API. How do I study comets? Yeah, well, we're working on that. How do I hear about outliers? You might be listening to our outgoing Kafka alert stream, or you can look at the web page, depending exactly what your kind of interaction that you're looking for. How do I get postage stamps? Well, you could either use the web interface if you have a small number of observations or objects that you want to track down, that's fine. Or you could use the API if you're interested in a more kind of bulk grab of some kind. How do I get a sticker? They're sitting right there on the table, so come see me after the session. Okay, conclusions. Lots of exciting science happening, which I didn't even really tell you about here, but trust me, it's happening. We're on track to have functionality for a web page and API by October 1st. That will serve both ZTF data, which is a very rich data set, and LSST, which will just be starting, but will immediately become a very rich data set, and also stickers available. Thank you very much.
I have one, so I'm going to ask. So Think can do some of the similar things that you're doing. Do you know their capabilities and Snap's capabilities, and can you compare and contrast?
Not in detail.
Okay.
Yeah.
That would maybe be really useful if that's something that can be on your website. So that way we know like where you're excelling versus what they're doing.
Yeah.
Because I think there may be overlap, but it sounds like there's some things that'll be coming online in Snaps that'll be really amazing. So trying to understand the differences would be
Yeah.
really helpful.
Thank you. At a higher level, the project is has built this new page with all the brokers on it. That's sort of, we've been invited to write 50 words about each of our web pages. And so there is some attempt at the project level to understand what each of the brokers does that overlaps and is unique. And I think that is helpful. I mean, anybody could use any broker for anything they want, but we want to direct people to the thing that's going to be the most useful for them. So that is happening that's happening at a higher level, but I take your comment. It's a good one.
Any other questions for David? Colin.
Is it free?
It is free.
Nice. I know they're not all free, so that's why I wanted to ask. Thank
It
you.
is free. The stickers are free too, Colin.
Nothing's free. It's just been paid for. Any other question? All right. Thank you. Thank you, David. This is amazing to see all this getting built up as we're getting ready to go into operations. And the final talk is going to begin by Laura Buchanan. I think Laura's online. Is that right?
Yes, I'm online. I can just share my screen now if you're ready.
I believe so. Let me just stop sharing here. Okay, go ahead.
Here we go. Okay, that's hopefully just sharing my desktop over there.
Yeah, we can see it.
That's great. Yes, I can actually see on the camera that it shows up fine. So yeah, I'm presenting on research announcements for the solar system, or RAFTS, as we're calling them. So this is a system that we're creating over at the CADC in Canada by a team of people you can see on the screen here. We've been getting feedback throughout by Tim and Henry as the current and former solar system working group leads. Back at the last solar system sprint, so last September, I did give a presentation of this, but in case people missed that, and also at that point, this system was essentially a Google Doc and a planet wasn't actually existing yet. But yeah, as a brief overview, what is this RAFT system? It's so we can announce short, citable, interesting science relevant specifically to the solar system.
Laura, can I interrupt you for a second? We're having
Sorry, you cut off.
I think it was us.
Okay. Okay. Should I start?
Right.
No, you're okay.
Yeah, if you can turn off your video just in case.
Oh yeah. Oh, I think my video is turned off, but yeah.
All right, perfect. So now we can hear you really well. So I hope it'll be okay.
Okay. Yeah, let me know if there's any other issues. I'll just go from the start of this slide again, on the assumption you missed that. So yeah, it's a system to issue short, citable announcement relevant specifically to solar system science. So along the same vein as like astronomer telegrams, but specifically for our science in the solar system. The system will be freely accessible to the entire solar system community. So although we're kind of building this with Ruben in mind, it doesn't have to be a Ruben-based announcement. It can be anything from the solar system. And each of these will include a permanent discovery distribution via a DOI, or digital object identifier. And on top of this, each announcement will have discussions facilitated via the LSST community forum. So discussion will be encouraged with these. As a kind of quick overview of what actually happens within this system, as the user, you submit your form of the raft, which I will actually demonstrate after this. It goes through moderator or reviewer approval. If there's any issues, it can go back to the user and cycle through however many times it takes, hopefully pretty quickly. And once it's approved, we get to this final third step where you get a DOI generated. The RAFT announcement and any of its data is publicly accessible on the CADC system. And at the same time of that, a community forum post can be generated where discussion can take place among the community. And kind of excitingly, we're at the stage where if I swap to this screen instead, I can actually show you what this system looks like. So we've got a nice little landing page with various information, various options of creating one of these rafts, viewing any that you've maybe started and are partway through, or ones that you've already submitted, or because I'm a reviewer in the system, I also have the option to review previously submitted rafts from other users. So if we jump straight into the create a raft, you can see we've got a nice little fillable form with various pages. If you're a first-time user, there's a tutorial that goes along with this, but I've been on this a few times, so it doesn't show up for me. In order to kind of cheat, I did create a raft earlier, which I'm just going to import so I don't have to type anything live on screen, which doesn't tend to go well. But just as a kind of demonstration, the kind of handy recent one is, of course, 3i. So I've just borrowed some information from the Atlas announcement from this. So you can include various authors. I've only included 2 with their ORCID IDs and various emails. You can continue to add authors as you'd like, or remove them if you've changed your mind about including them. If you've got a collaboration involved, that can also be added here. I'll just discard because I don't remember what I changed. You can give the information on what the actual announcement is. So in this case, it would be an interstellar object, which is obviously very exciting, but there's lots of options that you can include here with the name, some sort of abstract, and a figure if it's relevant, as well as acknowledgements, which are usually quite nice to include, or if it's relevant to a previous raft, like say there's some comet that did something interesting last year and it's done something interesting again, you want to relate back to that previous announcement, there's the option right here. Information on the object itself. So how was it observed? Does it have an NPC designation? Of course, some of these things may have only just been discovered, so they don't have an NPC designation as such. There's additional information. We've tried to include everything that you want, but most of it's not necessary. It's just relevant. So if you have a really interesting orbit, such as an interstellar object with its really high eccentricity, you can put that right here. You can include just general additional miscellaneous information. So this is stuff which isn't included in most announcements, but may be relevant to specifically yours. Like you've got a comet that has done something really weird with its AFRO, you can include this yourself, or like some sort of weird Yarkovsky drift. Not everyone wants to include that, but you might. And similarly, you can review and submit this raft. And we've also included the option that if someone really doesn't want any discussion to go on about their announcement, you can in fact opt out, which yes, is something which people liked. And obviously I imported this. You can freely import and export as you go if you want to share that information with co-authors. And I guess since this exists, this isn't fully ready, but you can see there is a reviewer system of things can be under review, they can be approved. Don't worry too much about what these titles are because they're just kind of filler information while we're setting things up. So I think I'm nearing the end of my time, but I'll just skip ahead then to the final information. I kind of covered the system features just by going through it. But as a summary, yeah, we've got a cool system to announce citable things to do with solar system science. We're kind of open to feedback or input at any time. I've got some contact emails here. Specifically, if you're interested in being a reviewer for this system, do please reach out. I've bolded my email because I'm happy to hear from you. We can't make any promises yet on dates, but our tentative end date is kind of start of September. So if people are at DPS in Helsinki, we might have a system up and running by then. The aim was always be ready for operations, which it does very much look like we'll proper science operations, sorry, not just the data previews. We should definitely be in place by then. And yeah, that's us ready to answer any questions.
Thank you, Laura. Okay, let's open it up for questions.
I've got a question / comment. So two things. You built a system and you want to be ready to go. Who's the beta testers for this? And have you had an open call? Because if this is intended for, the community, one thing that'd be really good is to have, like the MAST has the user group and Ruben has a user group. It seems like that's going to be really important for this. So who's the user group? Have you established that? And are there openings for people to join?
Currently we haven't. It's just been the people who I listed on the first slide have been internally testing this. But I think that, again, we don't have dates in place, but I think we have previously discussed, someone could maybe contradict me, but that before we properly open it to just any announcement being available, that we do some test runs first to make sure that everything's properly in place. And like, even whenever I was setting up this presentation, because we're still an in-progress system, I was finding bugs, and the more people are on it, the easier it is to find bugs. So yeah, that would make sense. And it's something that I think when it comes to time for that, we'll put something out for the probably likely the software working groups to see who's interested in doing that, as well as the reviewing, or maybe I should have said the slide reviewing or feedback, but I didn't think of it that way. But yeah, thank you. That's a useful question and comment.
Yeah, I guess I should have said, you probably know the voice, but it's Meg.
Oh, yeah.
The other comment I had, unless I see a question, and I don't see anything on Slack, was you talked about reviewing. ATELs don't have review. It's like, you have to be verified, and then they may do review in the first one, right? But like archive, you're verified, like other people say, yes, this person's gonna not post spam. You have a review system. So say 4i shows up, but I've never submitted. I'm now waiting for someone to review this. So then how, I guess my worry would be is I'm sitting in moderation and then I'm just going to go put it on Blue Sky instead. So just wondering you talked about this moderation. What is it? How is this model you envision such that it's going to be super quick rather than the more traditional sort of astronomers vouching for other astronomers and grad students that has been used in many of the other systems like Astronauts and ATELs?
Yeah, I think that on paper, our best effort is within 24 hours or within 1 day, without making immediate promises of that turnaround time. In the case of something like a new interstellar object coming in, I imagine the aim is to have a team of reviewers across multiple times, and so there's always someone who's going to be pretty much immediately on it, especially if it's something like that kind of quick you want turnaround. I think you mentioned about alternatively posting on Blue Sky or something like that. This, we're really hoping, will be a much nicer way of announcing versus posting on Blue Sky, just because it's one single thing. I know whenever 3i came in, someone messaged me and then I went searching for like a social media post, and that's really not ideal. But yeah, we're aiming for a quick turnaround, just within best efforts. The reason that we do want to have reviewers or moderation coming in is that we aren't being chalked up with a whole load of junk of someone's like, oh, we've got 10 new asteroids, let's put an announcement out for each of those. It's just best effort to avoid essentially that taking place.
All right, thank you, Laura. We're out of time, but if Henry has a 15-second question.
And if you have additional questions, you can post them on Slack, and yeah.
It's just a comment on Meg's thing. I mean, for me, I think we wouldn't want someone random who has never interacted with the system to announce a 4i. So I think kind of the intention of this is to have not just raw information spewing, to have a little bit of moderation, but not too much. But like Laura said, a light touch. So that's my understanding of the vision.
All right, on that note, I hope we can move that discussion to Slack and continue there. Thank you, Laura, again. And so we are amazingly on time and on budget. I have just two things that I want to leave you with as you're going. One is that in a year from now, this is going to be, you already feel that the optimism of this meeting. I think in a year from now, this is going to be a very different meeting. That's what we all hope for, where all of us are going to be reporting on first science. I do want to temper your enthusiasm a little bit. It will be incredibly bumpy. Expect a bumpy ride for the next couple of months, next year, really, as we learn how to tame this beast in many ways, and get the data out. We'll occasionally make mistakes. We'll occasionally make incredibly stupid mistakes. I'm going to apologize in advance for when we do that. It's not if, it's when. But I'm sure a year from now, we're going to have a lot of great science. And the second thing I want to leave you with is I hope to see some of you in Helsinki. We'll be there at DPS. That's almost 2 months from now. And I bet we're going to have a lot more new things to announce by then.
And there's a LSST session, so might want to come to that.
Yes. Thank you all again.
And don't forget your stickers up at the front.